All right, so in this lab, we're going to leverage a Java data structure, a DEC, to solve a problem. One of the hardest parts about programming is mapping data structures to real-world scenarios. For example, you are writing an inventory control program, or you're writing a ticketing program like Ticketmaster or what have you. A lot of times you have to map real-world situations onto a in-memory data structure. It's not always easy, right? Because a lot of the data structures, queues, stacks, trees, lists, it may not be directly evident as to what maps where. So in this case, we're trying to determine whether or not a string is a palindrome. A really good match for this problem would be to use the Java DEC. A DEC in Java is both a stack and a queue at the same time, meaning that you can treat it as a stack or you could treat it as a queue. So we're going to go through and we're going to use a DEC. We're going to solve the problem, which hopefully shows a way that we can leverage the properties of the data structure to help us solve an issue. So let's dig into the code. All right, so let's go over this lab. What I'm going to go over is just the high levels of what we need to do to implement this, this lab. And then, as always, go take a look at the tests I wrote so you know kind of where, so you know how to test your class to ensure it's right. So high level, right, we have app, myPalindrome, and palindrome. Palindrome is an interface that you have to implement in myPalindrome. App is the main, and you'll have to implement a very simple way to read from standard in and output whether or not the string is a palindrome. So let's go to the meat. Let's go to the palindrome tests. So on the surface, you may seem that there's not much to test when it comes to palindromes, but there are a surprising number of corner cases. If we look at the description, first thing we have to know is that the method ignores punctuation and spacing and treats all letters and numbers as case insensitive, right? So capital A, lowercase a is the same. And a one character string is a palindrome. So we need to make sure and test all that. So if we go over here, we can see where I have a palindrome. I have some punctuation. I have uppercase, lowercase. In fact, I might want to do this just to make it more robust. I have kayak with a bunch of exclamation points. I have noon, and then I have a mix of letters and numbers. Now, one thing to notice here is testing both even and odd combos. So kayak is 5 characters and noon is 4. You don't want to get into a trap where you may have everything as even characters and forget about odd or vice versa, because your code could be incorrect. So that's is palindrome. Next, we want to test digits. So it's kind of similar to this palindrome, but we're just going to do digits. So we can go 1 1 2 2 1 1 and then put some spaces. We can throw this obviously could be more robust as well. We can throw in some punctuation here to make sure that mixing in punctuation doesn't mess stuff up. Then, of course, we want to do the opposite, right? Is palindrome. We want to say not palindrome. So what I did is I took a lot of these strings I have in is palindrome that should return true, and I just put in some extra letters to make it false, right? So I added an extra T, an extra R, some extra R's, a whole bunch of extra R's, right? And then I just inserted false. Then I have test null, because one thing you got to do in your classes, right, is you always want to make sure your classes should be as robust as humanly possible, right? So if somebody passes you in a null string, you shouldn't fail with a null exception. Null pointer exception, null reference exception. So in this case, my string is null, and I knew up my class, my palindrome, and I pass in a null string, and it should return false, right? Is palindrome should return false on a null, because a null is nothing. So obviously it can, nothing is just that. It's nothing. It's not a palindrome. Now we have test 1, right? Because if we look back at our documentation, one character string is a palindrome. So I have A, and then assert that as true, and then I have A, and I put a whole bunch of characters on, punctuation, so to make sure that was all good to go. Then test only punct, right? So that's another thing, only punctuation. So what happens if I only have an exclamation point and only a whole bunch of punctuation? Well, that should be false, because this will go down to a 0 string. And by definition, a 1 character string is a palindrome, a 0 or null is not, right? So it has to have at least 1. So that should be false, false. Then I test empty, which is also false. So empty and null, right, they seem the same, right? But a null string is absence of a string, where a empty is a string, it's just there's nothing in it. So I know it can be confusing, right? Null and empty, but they are different, and we need a test for that. So that's the test. So if we go here and we can run the tests, we can actually run the tests, see if they work. So I'll just say great LW test, and hopefully everything works. And it looks like it's successful. So my solution, which is in my palindrome, which I'm not going to share because that's what you have to write. All tests passed. So let's go back over here and make sure we look at this at a high level, right? So we want to implement the my palindrome class, right? Implement the my palindrome class. Whoops. And just to be clear, we are required to use a deck. You have to use a deck. There are a lot of different ways to implement a palindrome. You are required to use a deck. I got some examples from dictionary.com. So if you click on dictionary.com, you can grab some more examples if you so wish. There's a whole bunch of them here. And then finally, input output. So we need to go into app.java, which is right here, and we need to complete that. And app.java will simply allow the user to input a palindrome from using the scanner class. And the scanner class will then call your isPalindrome method, and it'll just output yes or no. And here's an example of the output. So let's go and look at the deck class and talk a little bit about the deck class. So if we go, or sorry, actually I misspoke, the deck interface. Okay, so the deck is an interface. And what that means is the deck doesn't actually, there is no deck concrete class. There is no deck.java. It's just an interface, and there has to be a concrete data structure that implements it. In this case, we have 4 known implementing classes of the deck interface. Now, this is really cool because these two, concurrent linked deck and linked blocking deck, that's a little bit it's a little beyond the scope of this class. So we'll just concentrate on array deck and linked list. Now, array deck, if we look at this, we'll say a resizable array implementation of the deck interface. And a linked list is just that. It's just a linked list, doubly linked list implementation of the list and deck interfaces. Now, deciding whether or not an array deck or a linked list is appropriate for this particular instance, well, at this level, I don't think it matters a lot between array deck and linked list because we're not processing massive amounts of data. Once you start to get into big data, like huge data, huge input, huge output, inputs and outputs, it could make a difference between array deck and a linked list. I would say the linked list is a little bit more flexible when it comes to unknown input sizes. So meaning that if you have no idea how big the input size is, a linked list probably is going to be superior because the way that implementation works is it's very cheap to add and remove new nodes to a linked list. Where an array deck or an array list, if it's backed by an array, you may have to resize the backing array or reorder elements depending on how what you're working on. So a linked list could be better in that case. So let's go look down here. So basically a deck, it is a stack and a queue at the same time. So remember, a queue is first in, first out. So we have a whole bunch of queue methods here, and then we have the equivalent deck methods. So if you're used to, working with a queue, you can say, okay, in a queue, I say add. Well, the equivalent deck method would be add last, which kind of makes sense, right? Because a queue, if you think about it as a line in to buy movie theater tickets, you go to the end of the line. You add last. Okay, so stack, which would be push, would be a traditional method for a stack. The equivalent deck is add first, which kind of makes sense because in a stack, if you go with the image of a stack of plates at a buffet at a restaurant, then whenever you add a plate to the stack, the first one, the last one added is going to be the first one taken out. All right, so you'll add it to the front. So, right, and here it is, right? So decks can be used as LIFO, last in, first out, and a queue is a first in, first out. So if we go down here and we look at the potential methods that we can use, two things pop out. We have pull first, pull last, and we have remove first, remove last. Now on the surface, they look similar. Remove first, if we click on here, remove first. The difference is remove first throws an exception, where pull first simply returns null if the deck is empty. Now, in my opinion, for this particular algorithm, I think pull first and pull last are the correct ones to use, because remove first or remove last will require you to try catch blocks and do a lot more error handling than I feel is necessary for this type of application. Now, that's just specific to this lab. It's not a universal rule where pull first is always better. Sometimes remove first may be better because maybe you want to throw. Maybe you're going to rethrow that and you can't deal with it at the level, so you need this behavior. So there is no right answer about whether or not pull first or remove first is right. The answer is it depends on the situation. So I'm going to say we're going to use pull first and pull last. Another thing that we need to we can go look at is we can go here and we can look at let's do frames because I like frames. This is the old school way. So if we go to the character class, let's just kind of look at some other helper methods. So we have the character class, and there are some really cool helper methods that we can leverage, like is digit, is letter, or is letter. Oh, look at that! Is letter or digit. Ooh, that's pretty cool. That makes it handy. Let's look at this string class. Let's go down here to the string class, string, string, str. sta, there's a lot, there we go, string. If we go to string class, there are some helpers here as well. So if we search here, we can say to lower, and look at this. We can convert all the characters of string to lowercase using the rule. That's pretty handy. So those two helper classes may be useful when you're working on your implementation. So if we go back here, let's go back here. I think that is a good overview. We have implement my palindrome class. We have write our unit tests, which we have gone over. We have the input output. And as always, we want to fill out the retrospective once you're done to go over your experience, known issues or bugs, and sources used. So I hope that helps, and happy hacking.